Good evening and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want to introduce number 10 and I want to introduce this number 10 with activity 2. And activity 2 we are told that if W is the set of whole numbers starting from 0, 1, 2, 3 moving forward, Z plus is a set of positive integers starting from 1, 2, 3 moving forward. Z minus is a set of negative integers or negative numbers which end at -1. Coming from very far, -2, -3, -4, and going down. Draw a Venn diagram to show the relationship between W, Z plus, and Q. I want to refer you to the previous slide whereby we outlined what are natural numbers. Natural numbers are the same as positive integers because natural numbers are the numbers that we use to count 1, 2, 3 and moving forward. They are denoted by capital N. Z, they are actually integers, and integers comprise of both negative and positive integers. We are coming from far, -3, -2, -1, 0, 1, 2, 3, and moving forward. Those are integers. Integers comprise both negative and positive whole numbers. What about rational numbers? Rational numbers are the numbers that terminate. When that terminate, they include the whole numbers. They also include the recurring decimals, and they include numbers that can be expressed as fractions. Rational numbers do not include irrational numbers. Irrational numbers are the numbers that when you write them in decimals, they do not terminate and they do not recur. They are not recurring decimals, and the decimals themselves are not terminating. Like pi. Pi is 3.142 moving forward. There is no day that those numbers will repeat themselves in a sequence. That means recur. They will not recur. And they will not end. They will not terminate. Those are called irrational numbers. So rational numbers are whole numbers, 1, fractions, 2, and recurring decimals, and that is it. Now, part A of the question, draw Venn diagram to show the relationship between W, Z plus, and Q. W, Z plus, and Q. Let us discuss. The Z plus are all positive numbers, positive integers. W are all whole numbers, including 0. So it follows that the Z plus, all members of the Z plus are also members of W, because in Z plus we are finding 1, 2, 3, 4, 5 and continuing. And in W, instead of starting at 1, we are starting at 0 because we are talking about whole numbers. 0 is a whole number, but it is not a positive integer. 0 has no polarity. You cannot say -0 or +0. That is why it is not included when we are talking about positive integers. We don't have a 0. I don't know how to write a -0. I also don't know how to write a +0. So 0 has no polarity. And therefore, we would wish to say this, that Z plus is a subset of W. All members of the Z are included in W. What about Q? Q, rational numbers. Rational numbers are all numbers, whole numbers, negative integers, positive integers, all numbers apart from irrational numbers. Rational numbers, whole numbers, fractions, those which terminate, negative, and even positive. So in other words, the Z plus and W, as much as Z plus is a subset of W, then both of these, the Z plus and W, are a subset of Q, because they are all rational numbers. So how then do we draw that Venn diagram? It goes like this. This is part A. Inside, we have what we call Z plus. Immediately outside, we have what we are going to call W, because Z plus is a subset of W. And then there is all of them, there is what you're going to write as Q, because all of them are rational numbers. And that is how we can express that Venn diagram of part A of the question. What about part B? Part B explanation is that we have Z plus, Z minus, and R. Z plus, Z minus, and R. As much as we know Z plus and Z minus, no member of Z plus appears in Z minus, because Z plus we have all positive integers. All positive integers. Z minus, we have a set of all negative integers. They have no intersection. They don't share any number. They don't share any member. So they are, that is Z plus. Z plus include 1, 2, 3, 4 moving forward. And Z minus include minus 1, minus 2, minus 3, and moving forward. So this is Z minus, both of which are actually real numbers, because real numbers are any number, all numbers now, including the irrational numbers. They are real. How is irrational number real? I just want to give you a small example. For example, if we have a right angle triangle and we have an isosceles right angle triangle, and this is equals to that, and this is 1 centimeter, and this is 1 centimeter, and this is 90, you will agree with me that x here, 1 squared plus 1 squared, 1 squared plus 1 squared is equals to x squared. And 1 squared is 1, 1 squared is 1. This means that 1 plus 1 is equals to x squared. That means x squared is equals to 2. That means x is equals to the root of 2. So it is true that this is the root of 2. It is real. We can have a triangle that exactly looks like this, and this hypotenuse is equals to root 2. It is real, and we cannot change that. Yet, root 2 is irrational, because even if you are to write it as a decimal, it does not terminate, it does not recur. Therefore, positive integers, negative integers, they are all contained in, they are all real numbers, including others that we are not seeing or we are not having in this particular question. They are all real numbers. So that is how we can respond to that question. Let us meet in the next video. Thank you.